Hey, hello, welcome to the show. Look, it's me, John Park, and this is John Park's Workshop. We're in it right now together. Thank you very, very much for joining, for stopping by over in the chat. I think there was some confusion about times, but hopefully that's all worked out. Hello, Connor McCarter and Dave Odessa. Charles Burniford, thanks for stopping by the YouTube chat. If you're elsewhere and you're wondering where is all the chat happening, well, this is a good place to check out. That right there is our Discord server. You can hop over to adafruit.it/discord, and that'll give you an instant invite link over to the Discord server. And then you're just going to look for that live broadcast chat channel right there. We have a bunch of channels, a bunch of stuff going on. But the live broadcast chat channel is the place to be when we have a live stream going on. So hello to everyone for stopping by over there. We've got Andy Calloway, hello, and Paul Cutler, Thin Man, thank you. Charles Burniford, thanks for stopping in. So what do we got going on here today? Off last week for Thanksgiving, so hopefully you had a good Thanksgiving break if that's something you're up to. I just noticed over here, look, I found this. I was looking through a box, we were moving stuff, and I found this old, not that old, but fairly, I don't know, 10 years ago old, oh no, 2017, not that old, Mario, Super Mario 3 PDP Pixel Pal. I might take this apart and see if we can do something with it. It just lights up. It has 2 AA batteries, no timer. It just drains them in a day and they're gone because it just has an on-off switch. And I was thinking of doing something with that sometime. Not today, but I just noticed it there in the shot. So, and there's another one. You might have seen it right there. That's a little Mega Man one that I hadn't lost. I knew that one was. Curtain is mostly gone. Yeah, actually, I just pulled it off to the sides. I have a what do you call it? Backdrop stand there with that hung on it. Yeah, I was mostly using that for some of the DMX spotlight, washlight stuff. But today we're doing DMX in reverse. If you saw the show and tell last night, I showed a little bit of that, a little bit of the stuff that we're working on, and I fixed my problem with it, which I'll tell you why it was acting funny. Mostly an orders of magnitude issue with a variable that I updated right before the show. And I will also today have a coupon code for you if you want to go to the Adafruit store and buy some neat stuff. This is the shop right here, adafruit.com. That's our store. Go there. You'll find we've got a whole bunch of new products here, some gift guides, some categories you can click on, featured products. We have a new products section. You can just go to what's new. That'll show you all the latest, greatest stuff that's out there. We got a few cool things there to check out. All of the product categories here. So if you want to get some stuff today, Refill, that's our coupon code, and that'll be pertinent to our CAD tips and tricks thing and a little mini project I have going. But that's the coupon code if maybe you want to fill up on some new parts for all the things you're working on. Refill, that'll get you 10% off in the store today. So just remember that and head on over to the store. On your way out, there's a little place to type in your coupon code, and that's good on things, but not concepts. So we don't give a discount on gift certificates, subscriptions, or software, but physical stuff we can send, that we can put in the mail and get to you. That'll work for those. Also, if you want to get some extra bonus savings by spending more, what could be more American than that? Go to adafruit.com/free. And there you will see we have some incentives for spending more. $99 or more, you get a free PCB coaster. $149 or more, you get the KB2040 microcontroller and the coaster. If you spend $199 or more, you will get free UPS ground shipping in the continental US, plus the KB2040 and the coaster. And then if you spend $299 or more, you're going to get a Circuit Playground Express, super cool microcontroller board, and the ground shipping, and the KB2040, and the coaster, all for free. So those are some of our incentives. You can check them out at adafruit.com/free if you're curious about those and more. Let's see, what else have we got? So we've got a recap I'll do of the product pick of the week this week. I've got a new pretty snazzy CircuitPython Parsec, continuing to build on the previous ones we've been doing with some Vector I/O, display, and touch I/O things. I've got a project update. We'll look at some of the DMX receiving stuff, and I'll do some demos there and show you what's going on with that, why that's cool, tinker with that a little bit. And then also I've got a CAD tip and trick related to the little mini project that I have going on, which is related in turn to our coupon code. So everything is sort of full circle. Okay, so to start off with, let's take a look at the product pick of the week recap. So that's my product pick show that happens on Tuesdays. Every Tuesday, I pick a new thing from the store, or sometimes an oldie but goodie, and give you a demo and a huge discount that's good just during the show. We live stream the show from inside the product page. This week it was this cool MEMS microphone, and here is a little 1-minute recap. I2S MEMS microphone breakout. It is the ICS43434. You can see here I've got I2S lines, power and ground, and the feather connected here. I'm running it over USB, and that's because we want to see the serial output. This is the serial plotter for Arduino, and you can see as I'm speaking, you can see the waveform changing there. I'm going to try to sing a pretty pure tone, so you should see a nice smooth sine wave. And then I like to try to practice overtone singing, where you kind of change the shape of your mouth and the position of your tongue to enhance a bunch of the harmonics. It is the I2S MEMS microphone breakout. It's the ICS43434. Indeed it is. So let's find out what you're using them for. We had a bunch of people buy those yesterday. These are, where'd mine go? I just lost it already. Here's the one that's on that breakout board on the breadboard there. Super tiny, very cool little mic, great for all kinds of projects. What are you going to use yours for? I have not tried the stereo thing with it, but I think it's pretty interesting for triangulation stuff if you want to do like robots that look for sounds and try to zero in on them. Nice use of stereo potentially there. Let's see, what else? I'm just noticing over in the Discord we have some shenanigans here with some new ideas in the store. Todd says, 1 good wishes from Adafruit, $0. 10 JPEGs of Zener diodes, $0. Sure, yeah, we can accommodate. See, Grover says, the JPEG of Lars hiding in pitch black lighting, $1. Hey, all right. Okay, so moving right along then. We have a CircuitPython Parsec. Let's do it. CircuitPython Parsec. Okay, check it out. For the CircuitPython Parsec today, I want to show you how to continue building a drawing tool using Vector I/O and Touch I/O. So here I have a touch screen and I have 3 points. And I'll go ahead and move a little closer here. Let's tweak that exposure. Let me just check the focus. That looks pretty good. So here you can see what happens is as I move any of these 3 points, I'm going to reveal a triangle which I can reshape and resize just by moving points around. This will work with your finger. It's a resistive display on this PyPortal, but I figured it'd be a little easier for you to see what's going on if I use the stylus here, but nothing magical there about the stylus. That could be anything. So how does this all work? Let's check it out. In the code here I have the display I/O and vector I/O libraries doing the heavy lifting. I'm also using the touch screen library so I can grab the position X, Y axes on the display there as I touch it. And then I'm creating 3 circles using vector I/O, and I'm making those big enough to sort of see and grab. I have a radius of 10 here that I'm using. And I'm giving them different colors using pixel shaders. And then I create a triangle using the Vector I/O polygon object. So you can see these were circle, but this one is made from polygon. And you can give it as many points as is reasonable. In this case, it's just grabbing from the X, Y positions of my 3 triangles in this list here called triangle points. And then I give that a pixel shader. Then I append those to the main group so they show up and set up the touch screen here. And then we have some variables here to keep track of when we're moving either circle 1, circle 2, or circle 3 so that we don't accidentally grab multiple points. So I'm only going to pay attention to 1 point that I'm moving around there. The main loop here, we look for a touch point. This touchscreen.touchPoint command, so that just says, hey, is the screen getting touched? Yes or no? And then we say, is the place that we're touching it on top of one of those circles? Yes or no? So that's the next check there. The way that we do this is comparing the XY coordinate of where we've touched to the centroid of the circles using this formula here, which is the touch X position minus the circle X position squared plus Y minus Y squared. And then if that's less than or equal to the radius squared, then we're inside the circle. Then we set that variable state to say, yeah, we're dragging one of the circles right now. This is true. And then depending on if that state is true, we start moving around the XY position of the circle itself using dragged circle X and dragged circle Y. And then at the same time, we're updating the triangle points. So any of those 3 circles XY positions become the new XY positions of the triangle. And then when we're done, when we stop touching it with this else here, we reset those variables to say, okay, the state of these is false, nothing's being moved around. And then we have a little bit of a delay there for some smoother dragging. And so that is how you can create an editable triangle in Touch I/O and Vector I/O inside of CircuitPython. And that is your CircuitPython Parsec. CircuitPython Parsec. I like this, I don't like that Lars, oh my gosh, that's horrifying, but I do like this. Todd said, hey, you're making Illustrator for CircuitPython as a series of parsecs. That's right. If you add up the last 4 or 5 of these, you're very slowly going to recreate Adobe Illustrator or freehand. Remember, what was it, Macromedia freehand? I forget who owned it before that. But yeah, vector programs are great fun. Sorry, I was just playing around with it there and not showing you. Great fun to mess around with. Also, just as a side note, the color scheme here, it's a little off from what I wanted, but it's inspired by the original PlayStation logo colors because it's I think yesterday or today is the 30th anniversary. Maybe it's yesterday or the day before. 30th anniversary of the original PlayStation coming out, so they've been relaunching some of the skins for the PlayStation 5 now to look like original PlayStation things. They've come out with these anniversary edition controllers and stuff that have that old school PlayStation logo, so I had PlayStation on the mind and I grabbed some of those colors there. They didn't quite, I didn't fine tune them. They didn't quite come out as green as I wanted on the screen there for the green, but yes, very excited about all that PlayStation stuff. When you restart your PlayStation, if you have a PlayStation 5, it will boot with the old school sound. It's fantastic. Very, very nostalgia inducing. So go check that out if you're a PlayStation person, Sony person. Very cool. All right, let's move forward then and move on. What have we got? We've got. Let's dive into some of this DMX stuff. How about? So I'm going to jump to the workbench for this, and I'll throw a main view up here. Let me make that just a little bit bigger, and you should be able to see that there. So where's my setup? Is it over there already? Oh, no, it's right behind me. Okay, I'm going to carry this stuff over there. So what I've got are a microcontroller, in this case an Arduino Uno, and a shield for DMX send and receive. And I got a bunch of NeoPixel strands all over the place, so let me neaten that up, move those out of the way there. And what you can see here is I've got, zoom in a little bit more, I've got a DMX controller and a very coiled up XLR cable. I'm going to neaten this up. I'll plug that back in a second. So this DMX controller sends out DMX512 messages that allows us to get values from 0 to 255 on 512 different channels of DMX, which typically would be one channel for the brightness of a lamp, or 4 channels for brightness, red, green, blue of a color, RGB color lamp. Maybe 6 channels because you've also got a pan and a tilt on that lamp. So DMX controllers and boards and software meant to run theatrical lights, but we're going to use this shield instead to say, hey, I've got NeoPixels, or I've got a motor, or I've got a servo. I want to control those things using all this cheap, excellent, or not always cheap, but sometimes cheap, and pretty good DMX gear that lives out there in the theatrical world and in the architectural world. So using the XLR cable here, I'm going to connect it to this shield. And that means that any messages that are being sent on channels that this is listening to, I can then do stuff like translate that into some NeoPixel lighting. I have a strip of NeoPixels. You can probably see little white dots there. I just put them in some Coroplast. This was for a lightsaber-ish project I had made years ago, but this was a nice one for this kind of display, I think. And all I need to do is, I've given this DMX controller power. I'm going to power up the Arduino here, and it's going to provide the 5 volts to this NeoPixel strip because it's a pretty short strip. However, with a larger strip or multiple sets of NeoPixels, you might use external power and just a common ground. So when I give this Arduino power, the first thing you'll notice, I'll do this again, zoom in just a tiny bit. The first thing I do here is a little sanity check. You wouldn't always want this, but while I'm coding and debugging, when I fire up the Arduino, I run this through red, green, blue, in that order. And that's important because a lot of different fixtures and NeoPixel strips and strands, for example, these nice star-shaped ones, don't have the same color order as each other. So this one is like green, red, blue. This one is blue, green, red. So the messages that they're receiving will light up different diodes in different orders, just kind of depending on the manufacturer and the chip that they're using. So that's kind of a nice little trick when you first turn it on. Just make sure you've got things right out of the gate. Okay, yeah, that just went red to green to blue. I know that I have the right pixel order in software running in Arduino here. Before I go any further, I'm also going to get my coffee and turn on my Discord chat here just so I can keep an eye on things and make sure audio and other technical things are working. C. Grover said a nice use would be DMX to control a telephone ringer. Yeah, you know, in theatrical stuff, props can be triggered with DMX, and this is a nice way to go about it. You might not find someone has manufactured a thing that does exactly what you need for a prop or an effect, but since theatrical settings are just full of DMX controllers, it's pretty easy for someone to assign a channel to a particular effect or prop. Let's grab my broadcast chat. Hopefully the phone will stay on. I can keep an eye on that there. So now with this on, and the shield enabled, I'm going to tell the controller to start sending out on channel 1. And let me increase the, let's see, this should be working, so I'll make sure that I didn't break something. Let me, okay, you're actually on. Okay. So I'm going to lower the brightness here, which is this. I've got two brightness settings, essentially the first pixel. Should I reverse these? Let me put this here so that that's going to be easier to see without getting my hands in the way. There we go. So in the controller I have here, this one happens to have 8 faders on it, and they run in banks of 16. So right now with this button here, this first fader is going to go to channel 1. If I switch to this, it would go to channel 17 and so on. I can't remember on this one what the shift is over to the B set, which would be 9 through 16. Yeah, it's that. Okay, so this right here would change something on channel 9. If I go back to page A, it's going to change something on channel 1. So let's brighten those up a little bit, and let's tweak the saturation. So the way I've got these running right now, so this is the first pixel, and it's hue, saturation, brightness, or value, and the number of the pixel. So if I pull this all the way down, you can see I'm sending out 0 to 255. So if I send out a message of 0 on channel 4, my code says the first pixel we're going to use is pixel 0. There are 30 pixels in this strip right here. So if I say first pixel is going to be 0, I can then say the final pixel is going to be, let's say, pixel 4. 0, 1, 2, 3, 4. So I'm lighting up 4 pixels. The hue, let's say I set it to red for the first pixel. I can also set that to red for the last pixel. And now I've got just a red set of 5 pixels. By the way, I know my camera is displaying those as a little bit orangey. Let me see if adjusting the brightness changes anything. No, not much. That's just the tinting, the white balance on my camera. But pretend you see that as pretty red, which is what I see in the real world. So if I have these on pixel 0 to pixel 5, and I move them together, I can just change that little chunk in concert. It does freak out a little bit, I think, when the value wraps around the color wheel. I need to look and see if I'm mapping that properly. You'll see a little moment there where something funny happens with that interpolation. I'll show you how that's working in code in a second. So there is pixel 0 to 5. If I push this last fader, now I'll go all the way to pixel 30. It's just a pretty simple remapping. And we can move those together. So if we want to do like a little Larson scanner kind of thing, sort of. I don't have all the cool fade stuff, but essentially I can move those together to zip these pixels around, and it responds pretty quickly. So we can do some pretty cool little animations there, just hands-on with the fader. Now, the part that I don't even think I have the little booklet here. I've barely used this one, and I forget what the, I don't want to torture you with me going through the steps of trying to program this controller, but you can essentially go into a programming mode, set some values, record those as a scene, go to the next scene, the next scene, the next scene, and then create a chase of it jumping between scenes either progressively, or you can mix and match around. So those are all features of the controller. I don't know this one very well, so I won't subject you to that, but you can, and the way this is typically used in lighting is from cue to cue. You'll say, okay, my first cue is going to be, this is over here, then my second cue is going to be here, and change the color of the final pixel there. So you could record those things and play them back with the controller. I won't do that right now. I'm just going to play around with the manual controls of this. So here we have pixel 0 to, let's go up to pixel 30. And now as I adjust the colors, you can see I'm going from a red to a yellow. I'm going to drop the brightness a bit so you can see that a little better. And let me just check. Sometimes it's a little easier to see. Yeah, no, this is probably the best way to show that. So now we're doing an interpolation from red to a yellowish green. Keep pushing that up to green. So now you can see this last pixel and this first pixel, red, green, and we get a nice linear interpolation between them. I'll push this one up into cyan. Again, I'm getting a little like flip around the color wheel there or something that I'm not sure what's causing that. I don't like that. I gotta fix that. And then if we go from like a red to a magenta, you can see I think it's taken the short way around the color wheel there. And then the same in the other direction. So if I leave this pixel to red, I can start pushing the first pixel's color up, and again, until we kind of make that flip. Maybe it's at the 180 mark, I'm not sure, to adjust the interpolation or gradation between those, which is pretty cool. And this is not really something you'd find on a lighting fixture necessarily. It's kind of esoteric, but if this is the kind of control you want, then just using a microcontroller and a DMX shield on it and writing your own custom Arduino code means that you can take advantage of all of this great fader kind of stuff that we have and program it to do things that you wouldn't normally get to do. So I've got hue, I've got brightness that you've seen, I've got the pixel position, and then we also have saturation. So I'm leaving those cranked up here. If you take the saturation out, you basically get white. Again, I know this is going to appear a little bluish white. Actually, since I've got kind of warm color balance on my broadcast, it actually looks a little more neutral than it is in real life. This is a fairly blue color, and that is because this is a 3-element NeoPixel. It doesn't have a white diode in there. It's just red, green, and blue kind of all pushed. So as we adjust that, saturation, we're just heading towards white. So I can bring this back to some colors, and I'll bring that back to there. Now you can see also a thing that I did was I pulled off the default fader caps because I didn't feel like putting a piece of tape down here and writing names on them. So I just know I put the same kind of caps on these kind of black lined ones for refocus on there. These black with a little white line on them are my position ones. The saturation is got no caps on it. The brightness are these gray ones, and then color is the magenta one and the blue one here, just so I could kind of tell the two banks there. So let's see, what else can we do with that? This will work with pretty much any NeoPixel. Like I said, the star ones here are actually a different color temperature or a different color order. So if I set this to red, let's see if I can find one more jumper. Did I leave that somewhere else? I might not be able to demo that, but I was going to show these. These will show up wrong. These will probably all be blue if I plug them in right now. Let's see. I might have I'm using some little two-sided jumper cables to flip the. Is that one? That's not one. There's one, maybe. Yeah, that'll work. Okay, so this strip here has a JST connector, but I can plug DuPont connector jumper wires in like that. And let's do, I'm going to unplug this for a second here. We'll go to ground, 5 volt. And I'll actually just piggyback this on the same data line. So as long as the current is enough, these should do the same thing at the same time. And can I get that? Yeah, so that's on A0. So I'll plug this into A0. So these should both light up. And you can see how they went in different orders from each other. So watch, this one's correct, red, green, blue. And this one's going to go like blue, green, blue, red. Yeah, so it's in a very different color. But they will both react. It's just this one's not what I expect. So they'll never be the same. So 2 different strands, 1 set of channels controlling them right now. What I don't have set up in code right now, but is pretty straightforward to do, is to instantiate a second strand on a second pin, and then we can use a different bank of numbers. So I could hit over here to 17 as my first number, and then control this second strip, and on and on and on. This controller actually is weird in that it only does 192 channels, but DMX 512, most things will do 512 channels. So that gives you a whole slew of different lights that have RGB that you could control with them. Oh, what did I do? Did I break it? Are you still working? I broke something. Okay, good time to stop. Let me repower this, and I'll unplug that. Just make sure things are still generally working. Oh, I know what happened. I didn't change this back. I was changing channels that weren't being used. Okay, so let's take a look at the code there and how this is working. And let's do second. I'll get the Arduino code for this up, and let's just switch over to a screen. I can expand that screen where you can see this. There we go. Okay, so is this it? Yeah, so DMX receive, NeoPixels, HSV gradient. I will say once again, the library uses some outdated and offensive language for the names of the sending and the receiving side of the DMX, so I will gloss over that stuff, but it would be lovely to fork that and make it behave a little more appropriately. So I'm using this Conceptonetics library, and I'm using the NeoPixel library. This is an Arduino Uno I'm using. In the guide, I also mentioned a Metro 328P, a Metro 328, same will work the same. These are old libraries. These are old DMX boards. We are considering right now getting this working in CircuitPython with possibly a Featherwing, a DMX Featherwing that'll offer the 2 XLR plugs, so that's something to look forward to. You can see here I just have set up for, let's see, can you see that? You can't, sorry, this is, let me move this down. That you can see now, okay, sorry. So yeah, those are the 2 libraries that I'm bringing in. You can see I was messing around with 2 strands, but right now I'm back to just 1. So on pin A0 is where I have that NeoPixel strand, and I have it set up as 30 pins. I'm creating that with the GRB color order. That's the change. If I use those hearts and stars and spheres strips, those are BGR as the order. So if we change that right there, we would get the color, the proper color order. And then, oh, weird. Someone said that there are 2 YouTube streams going. Yes, that's my fault. There's something going on with how I'm broadcasting and rebroadcasting, so we get 2 streams. Sorry about that. That's confusing. Hopefully they're both fine. Okay, so now we're setting up the number of channels to listen to. We could get by with 4 in this case. It's just, it doesn't hurt it to be listening to 30. We could go all the way up to 512. I presume that it would deal with that fine. And then we have the main setup here where I'm setting up the receiving DMX and the receiving start address. So I'm setting that up to start on 1. I think it's less confusing to just leave things starting on 1. You don't want to say, oh, I'm starting on 17 and then we'll call 17 1. I don't have any reason to do sort of weird remapping like that, aliasing of them. And then we are starting up the pixels. This is my little light show of red, green, blue, and then I clear them. I have, right now this can be sort of neatened up into little loops, but right now I'm just being very explicit about setting up 8 channels. I'm actually, I think I'm just using 4 of them right now, right? Yeah. But I'm setting up these channels, and then in my main loop, we just run through and ask on the DMX receive side, what value, 0 to 255, are we getting on each of these 8 channels? Again, only 4 of them matter right now, I think, with this setup that I have. Is that right? No, 8. Of course, I'm using, yeah, I'm using both sets of pixels, the front and the last. So yeah, I am using 8. So I ask for their values, so we get things like 0, 127, 254, whatever those are. And then I'm creating a remapping for hue, since I set up my NeoPixel not to use RGB, but instead to use, find where I talk to one of them, set pixel color, pixels color HSV, huge saturation value. That means that we give it a number from 0 to 65,535 as the very fine gradient through the color wheel. So that remapping is for channel 1 and channel 4. So those are my 2 color sliders there. I say take my 0 to 255 and remap that to 0 to 65,535. Same with channel 4, sorry, 1 and 5, channels 1 and 5. Channel 4 is what's my first and last neopixel, and so there I'm remapping the 0 to 255 that we receive from the fader to be 0 to the number of pixels minus 1. So I have 30 pixels, so this will go, in this case, 0 to 29, which will allow us to change which pixels we're lighting up. And then here's where we set the individual pixels. So DMX just sends, I forget what the clock speed is on it, but it's just constantly sending that message, that 512 bytes of data just over and over again. So every time we receive that, we don't have to hit go, we don't have to look for changes. The controller just always sends the full message. In the case of that one, it only sends 192 channels instead of 512. And we get, first, I fill all the pixels black so that if we're changing the length of it, we can turn off pixels. And then I set the first pixel, which is whatever channel 4 says the first pixel is, to be this color, which is based on the hue value that we get from the channel 1 remap, and then the saturation and brightness are actually 0 to 255 anyway, so there's no remapping, those map directly. So that's the first pixel, and this is the last pixel right here. And then what we do is we go and interpolate. So that just handles lighting those 2 pixels. What we do with all of the ones in between is based on this little lerp function here. And that takes a floating point for a start and end value, and the number of steps that we're interpolating between, and returns the number that each of those pixels should be as it works its way through each of those. So we take the first pixel, which is channel 1, and the last pixel, which is channel 8, and we iterate through those to get a fraction, like how many are there, 4 between there, are there 19 between there, and then we are running through the color wheel from sort of point A, let's say it was red, to point B, let's say it was yellow, and we get each of those little red to orange to yellow values in between. Once we get those values, we set pixel, maybe this is pixel 2, and then 3, and then 4, and then 5, and then 6 to each of those little interpolated HSV values that we get. The hues are really what's being interpolated. And then we show them all. So you don't see a bunch of flickering and stuff. It doesn't, you know, crawl its way through those, because we set all those values, and then it's not until this display show hits that all of these pixel fill and pixel color calls happen. And then there's just a little delay in there to keep things smooth. So that is how that's running. I will look, and if anyone has any ideas about what I'm getting on that funky flip in the interpolation there, let me know. I'll try to dig into that further. One issue I'm having is that with this library and DMX Shield, I can't use serial print because it's already, serial's already in use, hardware serial's already in use. So I may just set up a little secondary microcontroller and display so that I can see values. I can't do prints right now. I can't print this stuff out. I haven't dug into that much, but maybe there's an easier way than that. But right now I'm not able to see, okay, what value is jumping up and spiking around as it flips to purple there in the middle. So that is it. That is what's going on with our little... Toddbot asks, do you guarantee that channel 4 value is always less than 8? No, I'm letting it, you can see if I go back over here, I'm letting it do a bad thing. So if you look at, let's change the colors on these. Let's go red to bluish. if I change the position of the first pixel and make it beyond, then we get this little thing because it can't interpolate between those. It doesn't like crash or anything, so it's kind of fun. It means that I can move the two color individual pixels if the channel 8 pixel is lower down the strip than the channel 4 pixel. But as soon as those cross, then we get the, but that's kind of a fun little accident there. It would probably be good to make that intentional and not just an accident and code for that, but that's what happens right now. Good question. All right, so last thing I wanted to do is just a little update on and a little bit of a CAD tips and tricks section on a little project I'm working on the side for me, for fun. I don't think any learn guides or anything are going to come out of it, so I'll keep it brief. But this is about pens. So I have a love for Pilot gel pens. These are the G2 sized ones, which are these kind of fat ones. And then I also really like the high-tech C ones, which are usually finer point and a thinner barrel. But there's a whole industry, cottage industry of people taking these Pilot gel pen refills, which do not dry out. They don't need to be covered, and building cool pens for them, like barrels essentially, or holders for them. So you can see this is the typical one there. It's like a ballpoint in that it's not covering it. It doesn't dry out. So you can just open these up, grab that. You can write with it, but it's a little wiggly. So people like to make, bored out stainless steel and titanium holders for them, which is pretty cool. And I thought that would be a kind of a fun little experiment. So if you look here in my Rhino session, and this stuff again, I'll say isn't a sales pitch for Rhino. This kind of stuff would work in pretty much any CAD or 3D modeling program. But you can see here, I basically took my calipers and took some precise measurements, fairly precise measurements of these Pilot G2 refills. That's them in millimeters right there, and that's a little profile of the pen. And if we go into a little perspective view, so all that stuff was just writing down numbers and punching them in and drawing some accurate lines. If I move this out of the way for a second and show the refill, which, hey, by the way, that's our coupon code for today. Dun, 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 refill. Get your 10% off with that. So this is pretty much just me revolving that, lathing that around, sweeping that around a circle to make a 3D model. So that's my starting point. I've got an accurate model. Now I can use this to build the holder around. So if you take a look at the next steps here in my parametric modeling section, I'm grabbing data and I'm porting it through nodes that do different things to the data. So here is, let's grab the pen. So I'm importing essentially in or referencing that object. I'm going to go ahead and hide the real one that I modeled. So now this is just the sort of referenced one. So it's just going to appear as this green sort of translucent thing. So I have that as kind of a little ghost that I can work with. And then I'm going to build up a little piece of stock metal or plastic that we could either bore out or 3D print, or however you want to make it out of layers. So if we take a look at this process, I'm going to start showing things. So I took a rectangle and again just drew that. There was no reason to be parametric about it. Just drew that, snapped to the center line of the pen. Put some rounded corners on it, moved it up above a certain amount, and that certain amount I move it is based on this little slider here, so I can go and change how high or low that is with some precision. I made it a fairly tight boundary. And then I'm also going to sort of make a mirror flipped version of it so that I can extrude both above and below it a symmetrical amount. So this is me making a little extrusion from my curve, and I can reshape that curve if I adjust that and bring that in whatever sort of blank stock piece that I start from. That'll be the shape that we extrude. And then I'll put a little cap around that. Let me go ahead and hide some of these here. So now I have this little piece of blank here, and what I'll do is hide the pen and use it to dig out or carve out, or Boolean difference in this case, a chunk from the pen. So let me hide this one. So now I have this, get this out of the way, this very accurately bored out. You could maybe do that on a lathe. It's going to be a lot easier to 3D print it, however, that matches the shape of that pen really accurately, as I was able to measure it at least. And so now I can take that and either continue to adjust the design, go for a completely different design, but I know that I have a good starting point to be able to, in this case, 3D print out a little holder that I should be able to slide one of those into. Now, tolerances of 3D printing, I might have to do some negative wall adjustment just in my slicer to take this model that basically is, just right up on it. Or I could do a little bit of offsetting in here. I could essentially offset the surface of the thing I'm using to cut out to deal with the tolerances of whatever manufacturing method I have. I did a little export of those so that I could render them nicely. So if you look at these here, there's a orientation that might print well. That's what I used here. It actually printed pretty decently. And then all of the little dimension lines that you see there. So that has the profile of that pen in there. If we jump to a down view, I just printed this before the show, and it is too tight for sure. So I did like a negative 0.03 wall thing, and you've got some little busted, or what do you call them? Little fuzzies from my 3D print there. So I won't push this all the way, and I did it with one before. You can see the tip is there, but it's not all the way through. I pushed one all the way through and was able to write with it. It's nice. Here's my little very flat pen holder. But when I went to remove it before the show, I actually pulled the pen apart, so I made a mess. Not in here, but this came right off of there, and some ink went flying. Luckily, it's not super permanent. So definitely need to save a dried up one for further experimentation probably, and adjust some of that tolerance there, just because 3D printing is a little imprecise and ends up with a lot of little bits and pieces that probably need to be shaved out of there. If you're not going to clean it up, then I just got to make it bigger. But that's the idea behind it. My inspiration for this I wanted to show is, I actually was at a conference years and years ago, Foo Camp, and there was a brand new Kickstarter that had just happened or was about to happen from CWNT, who are a design team, and they were making this beautiful thing. So this is called the Pen Type A. It takes the thinner ones, which are the High-Tech C refills, and is this very super precise, machined, gorgeous pen that pulls out of this solid rectangle ruler thing, and it's got such tight tolerances that it, like, when you pop it out, flip it around and use it as shown. So that was the inspiration, was just, hey, what does it take to get your model accurate enough to conceive of these kinds of things. There's their piston action of how slowly that goes in. And they have a newer pen, the Pen Type C, that I really love, and it is this, again, the High-Tech C Coletto refills are super thin, and so this is a very flat pen. You can see that's obviously my design inspiration there, that has a little clip that flips around to just sort of protect the tip, but again, the tip doesn't dry out, so it doesn't need to be capped, but this is just to help it not accidentally draw all over your notebook. And this one has a nice clip on it to act sort of like a bookmark. So that's kind of what I'm going for there, and what this little experiment is about. Right, where'd you go? Here. As I put that together. So that is it. Let me know if you have any questions about any of the modeling techniques in there. I'm not doing this tutorial style and going into a ton of detail, but the basic steps are I'm bringing in that rectangular curve. Let me hide this stuff for a second. Let me show all of these parts at once and then flip through them. Preview on, and so here is that curve I'm bringing in. I'm putting a small little rounding on the corners, a little fillet there that you can see. It's the original curve. That's all this block does. This block moves my curve up. So there's the original and the moved version. And then we extrude in two directions, up and down. So just extrude up and down at the same time. This adjusts how high that is, and actually, if you look at the final result there, you can kind of see as we adjust that height, we can get to where we would have two pieces here that are not connected, up through to almost entirely, but not entirely, covering it. So really useful technique, though, is just doing a nice Boolean difference to cut something out of another thing. And 3D printing makes it pretty doable to create that. That would be a pain in the neck to try to bore out without a rifle boring lathe or something like that, just because it's long and hard to get to that with any kind of rigidity of the tooling. All right, so that covers that. I will be finishing up the code there and hopefully fixing the couple little bugs with DMX output and finishing that guide. I have the first part of it finished with sending out DMX from the Arduino. This will be the final page, which is bringing it in. And then you'll have a good starting point, I think, if you want to go ahead and play around with that stuff. And then hopefully we'll have DMX stuff in the future. I'll take a look at the CircuitPython library that the community has created. We should be putting together a feather wing for that, and you'll be able to do some cool DMX stuff. So before I go, once again, this is your coupon code refill. If you want to get 10% off in the store today, go Adafruit.com, use that. Thanks everyone for coming over into the chat. For Adafruit Industries, this has been John Park's workshop right here in my workshop. It's me, John Park. See you next time. Bye-bye.